Hey, I'm a mechanical engineer, and this is my experimental new lifter. Now if you watched last week's video, you'll know that video was all about my Battlebot's lifter, and that lifter works great and there's nothing wrong with it. However, I have thought of a new style of lifter that I want to build and experiment with to see if it'll actually work. And depending on how well it works, I might replace the old lifter or I might not. I haven't decided just yet. But this video is meant to be more of tests and experiments to see if the actual concept will work and if it is practical. I hope to finish today's video with the working prototype, but with that being said, the prototype will not be perfect. I can almost guarantee it'll still need some fine-tuning and adjustments done to it. But that's completely okay, because today is just about testing to see if the concept will actually work. So without any further ado, let's go ahead and jump right into it. So to begin, as you can see, I cut a track in the front top of my robot just big enough to fit my aluminum lifting arm. This lifting arm is just a 3-walled piece of aluminum I picked up at Home Depot. There's an angle cut at the front of it to match the angle of the Battlebot plate, a hole drilled in the back to fit a small aluminum pin into, and then of course the whole arm is cut down to perfectly match the hole in the robot. So now what I'm going to do is I'm going to take 2 small wood blocks and drill a hole in each one just large enough to snugly fit our aluminum pin into. And I'm just using wood for this test. I'll more than likely upgrade to something stronger further down the road. Just like these. I'm then going to slide the pin into one of the blocks, slide on the arm, and the other block. Like this. Next I'm going to take off the top of the robot, flip it upside down, then bolt our wood blocks of the assembly to the back of it. Like so. Next we're going to want to mount our lifting servo onto the base of the robot. We'll want to mount it towards the middle front of the robot. And we want to make sure that the servo's gear is just a little offset from the center of the robot. Because we'll be attaching an arm to that gear in just a minute, and we'll want that arm to be in the dead center. With the servo now mounted, I'm going to take 2 small pieces of Lexan, super glue them together, and then cut out a very basic lifting arm. Just like this one. As you can see, it's L-shaped, so it reaches from the servo to the front of the robot easily. And it's wide enough to where it can reach from the floor of the robot to the bottom of the aluminum arm. So after we attach the arm to the servo, we can close up the robot and do a few tests to see how it's coming along so far. So here we are with test 1. I'm just trying to make sure that everything lifts properly and that the general concept will work. So here we go. Actually seems to work quite nicely. And here we go with test 2. Yep, everything seems to be looking nice. Now as I'm sure you noticed, once the servo lifts this arm up, the arm just gets stuck and there's no way to bring it back down. That's completely fine. What I'm probably going to do is attach the servo to the arm with a string so that when the servo comes back down, it'll bring the arm back down. Now with that being said, a couple of you guys are probably worried about the string breaking, and I suppose that it's possible, but I think it's highly unlikely because all the string will be used for will be to bring the plow back down. So we now know that this flipper concept does work, but can the Battlebot still flip itself back over? Oh, I actually wasn't expecting that. That actually works quite nicely. So this thing can actually flip itself over. I was thinking I was going to have to put a spike on the top of this arm or something to help send it over, but it doesn't need any help at all. And something that's really cool about this is you should be able to use a standard 90-degree servo. Because the servo I'm using is actually a 180-degree servo, and I have to be extremely careful how far I take it when I bring it up. And since the servo is positioned more towards the front of the robot, you get a lot more lifting power. For instance, here's the box of nails I used in the last video. It weighs a little more than a pound, and this new lifter can handle it without any trouble. Now with all the benefits, there is a small setback. The servo does take up a lot of room inside. However, after repositioning a few things, I think this will be a problem that can be easily overcome. Having the aluminum lifting arm built into the robot also adds a lot to the strength factor. Because first off, it's a lot more difficult for other robots to even be able to get to it, let alone attack it. And secondly, it's a lot more stable because the frame holds it in place and stops it from moving to side. The only direction it could possibly go is up. Now lastly, as far as the actual lifting part of the lifter goes, I'm not going to build it in this video because it's going to be basically identical to the one in the last video. So if you have not already seen that video, I highly suggest you go ahead and check it out. There are still a few things that need to be worked out for this lifter, but so far I am loving it and I might just stick with this design. And there you have it, my new and improved lifter. But hey, thank you so much for you guys watching. I hope you did enjoy this video, and if you did, please feel free to hit the thumbs up and subscribe. And Lord, and I'll see you next Friday.
Thanks for watching, and please feel free to subscribe.